Good day, grade 11s. So today we are looking at what we call analytical geometry, question 4, November 2016. Okay, so we are having a question here. Reads, in the diagram, R and A are the X and Y intercepts, respectively, of the straight line AR. So we are told that your A and R, those are the intercepts of this line here. Now, the equation AR is Y is equals to, so we can actually label it negative half X plus 4. Another straight line cuts the y-axis at P here and passes through M and N, okay? Now, alpha and beta are the angles of inclination on the lines MN, and AR. So we've got alpha and beta. Now, before we start tackling the questions here, once you see these what you call the angles here, you must relate this. You know that tan theta. I'm just going to draw my own line here. Let's say here is theta here. Okay, so we know that tan theta is equals to gradient. So in this case, gradient MN, or we can say MP. Okay, that's what you must always know that. So this relationship here will actually help you to get the theta, to get also the gradient. Sometimes we might be given the angle, then you need to use this relationship to find what called the gradient. But now let's come to what called, and you see this line again, when you're given an equation, in analytical geometry, you must always know that these equations are in the form of y is equals to mx plus c, and your m is your gradient. So in this case here, m ar should be equals to negative half. So this information is for you to notice before you start tackling the questions. It's for you to notice very well before you tackle the questions, this relationship. Otherwise, when you start to tackle the questions, to read the questions, sometimes you might not what will recall this because of the exam fever and everything. Now, given that M, P, N are collinear, now when we're given that these lines are collinear lines have got same gradient. What do we mean by this? If they're collinear, it means that M gradient MP is equals to gradient M N is going to be equals to gradient M P N. That's what we have there. So gradient from this point to this point is equal to gradient of this point to this point, gradient of this one to this. So because they're in the same line. So now we want to find the value of K. So in this case here, we know that we're going to use these two coordinates to find the gradient. Then we write the formula for gradient using M and P. Okay, let's see here. M Pn is equals to 4 minus 2 over 3 minus 0. Then we get 4 minus 2 is 2, which is going to be 2 over 3. Now, 2 over 3. So now when we have got 2 over 3 there, okay, 2 over 3, that's your what you call, that's our gradient. Now we come and say, all right, let's equate it to MP. So we're gonna say MP is equals to 2 minus 0 over 0 minus K. That's what we have here. So what are we going to do? We're going to equate these two because they are equal. We know that they are what? They are equal. So because we are going to equate this and what is it? And this. So we're going to say 2 over minus K is equals to 2 over 3. That's what we have there. Then we take K that side, and take K that side, 3 that side. So what are we going to do? Multiply by 3K, because that's our what you call our common denominator there. Now what we have here, we have got 3 times 2 is going to give us 6. So we're going to say 2K is going to be equals to negative 6. Now K should be equals to negative 3. That's our answer at the end. From there, we can actually see that your K is actually on the what you call on the negative. So K is negative 3. We are done with that. Now let's move on to the next question. It's saying determine the size of theta, which is this the obtuse angle of the line. So now here, what are we going to do? First of all, we find the gradient. We have the gradient here, so we're going to use that relationship to say tan. We need to find theta, alpha, sorry. Then we need to find this angle here. Then we will subtract from 180 to get, what is it? We add them and subtract from 1 to get what you call theta there. So we're going to say tan alpha is equals to 2 over 3. So alpha is going to be equals to arctan of 2 over 3. Then let's see what we get there. We get arctan of 2 over 3. We get 33.69 degrees. Now that's what we have. Now how do we get beta? We're going to say again tan beta is equals to negative half, because that's our gradient here. That's our gradient, remember, negative half. Now the negative half, we're going to say arctan of negative 1 over 2. We get negative 26. So when you are saying, when you are getting negative 20, it's something for you to understand here. Negative 26 comma 57 degrees. Now here, what we are given here, it's actually this angle here, the negative. When you say negative, because remember tan is positive, it's negative in the second quadrant. So in this case here, this is actually 26.57. But otherwise, to get the obtuse angle, which is beta here, we get it by saying beta is going to be equals to 180 minus this angle. So we get 153.43. But remember what we want here? What we want is this angle here, 26. So we have got two of our angles here, interior angles. Here is 33.69. We're going to say, to get theta, we're going to say 180 minus, in the bracket, 33.69 plus 153.43. Then what do we get? We get, let's see here, 180 minus, in bracket, 33.69 plus 153.43. We get negative, okay, sorry, I made a mistake here. It's not supposed to be 153, it's supposed to be 26, sorry, 26.57. 26.57, sorry, just made a mistake there. 26.57. Now what do we get? We get 119.74 degrees. That's what we get there. Now from there we move on to another question, which is 4.3. 4.3 is saying calculate the length of MR. We know that MR, we need to find the coordinates first. We need to find the coordinates of R. How do we get the coordinates of R? We now make from the equation AR, we know that it's equals to y is equals to negative 1 over 2x plus 4. We make it, when y is equal to 0, we're going to say this is going to be equals to negative half x plus 4. We take the half that side, it's going to be half x is equals to 4x is going to give us 8. So in this case here, it's actually 8 and 0. That's our coordinate for R. So how do we get the length now? MR, we're going to say the coordinate, which is 8 minus, what is the coordinate for K? We know that K is, M is negative 3 minus 3. What do we get here? MR 8 plus 3, we get 11 units. So that's our length there. That's how we get the length. We're just subtracting here. There is no need for you to use that formula for what you call for the root and you are squaring x values. No need for that because they are in the straight line. Now, then here what we have got calculate area of triangle MNR. Triangle MNR. Let's check here. Triangle MNR. MNR. Now, MNR, remember, these are build-up questions. No, in most cases, they are build-up questions, meaning to say whatever you get on top, you might also is always in most cases it's helpful. It's actually helpful. What you call on the second question. Now, here we want to find triangle MNR, but the N, we don't have that line from N, so we can connect it to say from N to R. But when you look at this, what you call triangle, this is our perpendicular height. This is our perpendicular height. So perpendicular height, we are taking the value of what of y, which is 4 units. Then we have got MR already, which is our base. So we're going to say area in this case goes to half base times perpendicular height. What is our base? Our base, we find it, it's 11 times 11 times what? What is our height? Our height is 4. Then we get what? We get 2, we're gonna get 22 units squared because it's area. Okay, so guys, just these are the things to master when you're looking, when you're given a triangle like this. You must always know that you have to relate with the tan theta equal to your angle. Okay, until next time guys, thank you so much.